Okay, let's do lesson 7.7, the Law of Cosines, page 385 in your book. What is the Law of Cosines? So first of all, let's just take a look at our standard triangle, where we've got vertices capital A, B, and C, and opposite sides are the small letters. Small c is opposite of vertex C, capital C, small b opposite of B, and small a opposite of A. Given that, and that you have this triangle, the following conditions are true. A squared is equal to B squared plus C squared minus 2BC times the cosine of A. What is that really saying? That's saying if I want to know one side, the length of one side, I can figure it out by squaring it. Its square is equal to the square of the other two sides added together minus 2 times each of the other two sides times the cosine of the angle opposite the side I'm looking for. And that holds true for A squared, B squared, and C squared. They all work. Notice that in A, I was talking about B and C being squared. When I'm looking for B, I find A and C, and when I'm looking for C, I find A and B. And in each case, I multiply 2 times the two other sides, 2 times A and C here, and 2 times A and B here. And at the end, I'm always multiplying times the cosine of the angle opposite the side I'm looking for. So in this case, the cosine of C, right here, is opposite C, the small c, which is what I'm looking for. So at the end of this, you're always going to do a C square root to figure out the value of C. All right, when does this work? This works when you know two sides and an angle, or all 3 sides, side, 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 or side, angle, side. It has to be an included angle. Let's have an example here. Let's say we're told to find A in this triangle, and we know that angle A is 60 degrees. We know that side B, remember the side opposite the vertex B, is 10, and side C is 8. So we're looking for A, so jumping back up to our equations, we're going to use the first equation. All right, so let's repeat that first equation. And we know that A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. So let's fill that all in. A squared is equal to 10 squared, B squared, C squared is 8 squared, minus 2 times A and B, there's A and B, or sorry, in this case B and C. And then the cosine of the angle I know, cosine of 60, which is the side opposite the side I'm looking for. Okay, so once I do that, I get this nice formula, calculating things out. I then added those things together, took the square root of this side to make A squared into A with the square root. And then there's the square root, and I plug that into my calculator, and I get approximately 9.2. So A is 9.2 units long. Then we have the next example. Let's say we have this example. In this case, we know all 3 sides. What we don't know is any of the angles. So we're going to try and figure out one of the angles. How do we do that? Well, we're going to use the law of cosines again. And the law of cosines tells us that r squared, which is this 23 here, is equal to the other 2 sides, 18 and 37, each of them squared, added together, minus 2 times the other 2 squares, 18 and 37, times the cosine of r. Well, that's what we're going to figure out, is this angle right here, by doing the inverse function at the end. So we carry that down 1. I get 23 squared. Remember, the opposite side of r is 23 squared, equals 37 squared, which is that side. 18 squared is the other side, minus 2 times 37 times 18 times the cosine of r. I do that in math. 37 squared plus 18 squared is 1693. 23 squared is 529. 2 times 37 times 18 is 1332. Okay? Then I do that. I subtract the 1639 from each side, or 1693 from each side, and I end up with this. What I now have is a simple statement. I'm multiplying this number times the cosine of r, so I'm going to go ahead and get rid of that by dividing by negative 1332. And when I see that, do that, I get cosine of r is equal to approximately 0.8738. And I plug that in to the inverse function, cosine negative 1 of that 8738, 0.8738r, and my final answer r is approximately 21.9 or 29.1 degrees. Now let's take a look at the next example, and it kind of explains to us what we're supposed to do when we're solving for a triangle. We know the following things. We know that we have to decide how to solve the problem, and here's some rules for that. If we have a right triangle, then let's go ahead and use sine, cosine, tangent, and you remember SOHCAHTOA when you do that. If you don't have a right triangle, you're going to use either the law of sines or the law of cosines. Okay, so let's take a look. What if we're given this problem? Right there. This problem says I have side, angle, side known, but I don't know that side, and I want to solve for the whole triangle. So right off the bat, I'm going to say I'm going to use the law of cosines because I have side, angle, side. Okay, and I'm going to try and solve for k. So since I have the right angle, I'm going to go ahead and do that. All right. K squared is equal to the other two sides squared. So L squared and M squared minus 2 times L and M times the cosine of the angle K, opposite what I'm looking for. Plugging that all in, I get this calculation right here. And then calculating that out, take the square root of that whole thing, plug it into your calculator, you get K is equal to 14.2. So we now know that that value right there is 14.2. So we've got 3 sides figured out. So now we need to still figure out one of these 2 missing angles. What are we going to do? I'm going to use the law of sines now. In the law of sines, I say the sine of L, and I'll bring this down just a little bit so you can see it. The sine of L, this guy, over the length of its opposite side, small l, is equal to sine of k, 51, over k. So we have, plugging that in, sine of L over 18 is equal to sine of 51 over 14.2. Remember, we solved for k right here. So now, I cross multiply 18 times the sine of 51 and 14.2 times the sine of L. I then divide by 14.2 to get the sine of L by itself. I then do the reverse or inverse sine function or arc sine. And there I leave everything in the calculation, put it into my calculator and Web 2.0 Calc, and I end up with a very simple answer of 80 degrees for angle L. So now I come back up to my angle, and I know K, and I know angle L is 80. Now the only thing I've got left is angle M. And that's really simple to figure out when you know 2 sides of a triangle, or 2 angles of a triangle. You can figure out the third by subtracting from 180, and there you go. And finally, example 4 is an example where there's a real estate agent selling a plot of land, and they want to know the perimeter to this plot of land. And this plot of land looks something like this. Okay, looks something like this. 240 feet this way, 180 feet this way, 200 feet this way. We don't know how far this is, and it's a 60-degree angle here. Notice that this is a right triangle. This bottom triangle is the right triangle. So how would we solve this? Well, our logic will be, we'll use the Pythagorean theorem to get the hypotenuse, which is BD, segment BD. Then that will tell us side, angle, side of the other triangle. When we'll use the law of cosines to figure out the question mark, and then we have all the pieces we need to figure out the perimeter. So we use the law of cosines to get the side CD, and then we'll add up and do the perimeter. All right, so let's first do the Pythagorean theorem for this bottom triangle here. So we're going to say 180 squared plus 240 squared equals c squared. 180, 240, c squared. That ends up being 90,000 equals c squared. Square root of 90,000 is 300. So side C is 300, and that's the segment BD, right there, BD. Okay. Now I'm going to ignore this. I started writing this using single letters, and I decided to write it using the segment names. So now we're going to use the law of cosines. And so we want to say CD, the question mark side, squared is equal to the other two sides. Well, we just figured out BD. BC is 200. BD was our 300 that we just figured out, minus 2 times BC and BD, times the cosine of the degree we know, angle B up here, 60. So plugging all those numbers in, just as I said, and calculating them out, we end up with CD squared is equal to 130,000 minus 120,000 times cosine of 60. And doing the square root of that, leaving that all in there so my calculator can do it all at once. And I type it into the calculator, and now CD is approximately 264.6 feet. So coming back to our perimeter, we have to add 264.6. Let's see if I can get it all on the same page. There's the 264.6. Okay, that goes right here. And then add the other pieces, and all those added together are right here. 180 plus 200 plus 264.6 plus 280 means that our perimeter is 884.6 feet, approximately.